to an indeterminate quotient so you can then apply the L'Hopital's rule, right? L'Hopital's rule does not state, well, when you have an indeterminate product, you take the derivative of each one and then remake that product. That's not how it works. It's only for quotients.
So
okay?
would it be x over sine of x?
That's the most obvious thing to do, right?
And then that would equal 1. Because
Slow down. Give me 1 second. X over...
was 0.
Roger, how do you know that's true? How do you
It
know
says
it's
0 because the trig rules that we used earlier. It's
right,
0.
one we
It's
use
not
other.
1.
This is simply the reciprocal
Yeah.
of the original trig limit we learned before, which we don't really have to use anymore, thanks to L'Hopital's rule. But Roger remembers that this is 1, right? Let's say you didn't remember that. What would you do next? Take the derivative top and bottom.
It's 0.
It's 0 case now, right? Since it's now an indeterminate quotient, well, L'Hopital's rule does apply. So since it is now a indeterminate quotient, apply L'Hopital's rule and take derivative. So limit of 1 over cosine x as x heads towards 0, and what do we get? 1, like you described.
Okay, so in the first step, so when we first started, it was 0 times infinity case.
Correct. So all of these indeterminate forms, the product we just showed and the other two which we'll show in a moment, we're always going to change them to the indeterminate quotient case.
Okay.
So you can then use L'Hopital's rule.
Okay, and so then, in that step, so then we found the derivative of the second one?
This one, yes. We did not do anything except change the just the way it looks.
Now, why?
Cosecant is 1 on sine, right?
Now, I mean, why did we do that?
So it's quotient now. So that we can use L'Hopital's rule.
Oh, okay.
That's all. Always change it to quotients. Hey, ready to do a more exciting one? Number 34, and I'll show you the difference one. Limit of sine x times the root of 1 minus x over x. X is approaching 0. This time Lee will be more satisfied. It has it from the right. There you go. Probably more for this guy here. Okay, so I see it's a product, and it looks frightening. So it's probably an indeterminate product. But you want to make sure. So certainly, sine of 0 would be 0. So the outer part here, the left-hand part, I should say, is heading towards 0. So then I anticipate that this is heading towards infinity of some sort. And I need to make sure. Well, as x goes to 0 inside this piece, so 1 minus 0 is 1, over 0 would be infinitely large, right? And the root of something that's infinitely large is still
Infinity large.
yeah. So it is a 0 times infinity case. It is positive then. All right. So I need to make this into an indeterminate quotient. Or not.
You can always take sine and turn it to 1 over cosecant.
Or cosecant?
And then you can do 1 times square root of 1 of x, 1 minus x over x. So you have that over cosecant.
Good. Good. Now this thing already has a ratio in it, right? This already has a fraction in it. Play that.
So you can just push that down.
Okay. If we push it down, we'll have to flip it, right?
Yeah.
Okay. So this will be the same as sine x over the root of x over 1 minus x. This is one approach. I think it's the most obvious thing you guys would do. That's what I'm putting it there. Okay, so what case is it now? If sine x is function, I'm on the notation there. This is f, and down here is g. Then this heading towards 0, and what's this heading towards? 0. Everybody agree? Heading towards 0, right?
Wait, hold on.
Because we flipped it. So now this heading towards 0, this heading towards 1. 0 over 1 is 0. The root of 0, 0. So it is now a 0 over 0 case, right? Sine x is one function, and then the root of x over 1 minus x is the other one. So now we have an indeterminate quotient, which we want. So now we apply L'Hopital's rule. We take the derivative of top and bottom. Equals. L'Hopital's. Then this x goes to 0 on the right of cos x over, I'm going to take the derivative of that thing, unfortunately.
So 1/2 on the right side.
All right.
1/2 times x over.
I'm just gonna write this as a little bit sideways since it is a little tricky. So I'll write the 1/2 notation. You guys are just suggesting a power rule here, which is a good idea. Okay, so that derivative we need down here in the denominator is the 1/2 we just mentioned. The inner function stays the same. Lower the power by 1 to negative 1/2. Now I take the derivative of the inner x over 1 minus x. So what's the derivative of x over 1 minus x? You want to use a quadrant rule, I guess?
Yeah.
Okay? So this part here is going to be bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay? So we have 1, and we have negative x plus x. So we have a 1 down here, right? The numerator down here is a 1. So 1 over
1 minus x squared.
yeah, you can change this up to the 1 to the square now, doesn't matter. But I'll leave it the same. I won't figure out cents, I guess.
How'd you get the 1 by itself?
Because that's that 1 right there. 1 times 1. And this is negative x, and this is plus x. So they went away. Alright, so the bottom, we just trace our steps back now. It's a little confusing. So, we're looking right here. So, it's 1 over 2, but that's down here with this thing. The 2 is down here with 1 minus x squared, right? I'll just write it. So, this became what? 1 minus x root over 2 the root of x 1 minus x 1 of these squares. You buy that?
Where's the root?
Well, that 1/2. What does negative mean? Reciprocal, right? Negative is reciprocal. What's 1/2 mean? Root. So I took the reciprocal of this, so the 1 minus x has root on it, and the x down below has root on it. 1 minus x squared was below, right? You can see it below, there it is. 2 is below, so there it is. Okay? That's how I'm choosing to write it right now. Now I have in the denominator expression, root of 1 minus x, 2 root x, 1 minus x, 1 of x squared. Okay, so just analyze it carefully, okay? I know it looks horrible, right? But I think we're basically done. If you just look at it properly. First of all, what's the top heading towards now?
1.
1. That's heading towards 1. So, since the top is heading towards 1, even if down here should be heading towards infinity, the answer would be 0. If down here is heading towards 0, the answer is infinity, and I'm done. Right? So once you get a fixed value for something, that's a good, a non-zero value, fixed non-zero value, right? That's a good deal, regardless of whatever the second one is. So we know the top's heading towards 1, so it's all dependent on what's going on down here. So as x goes towards 0, the root of 1 minus 0 is 1, right? So now it's 1 over 1 over 0, right? Where's that 0? Blue. This is the root x, right? Root x. So I have 1 over 1 over 0.
That's 0.
What do you say?
0.
0. Agree? So the top's heading towards 1, and the bottom, this piece, this whole thing, is a 1 over 0 case. What's 1 over 0? Infinity. So what's 1 over infinity?